In handout 5, we are going to be looking at digit problems. So this is a typical kind of problem they use to set up systems of equations, to understand where you might end up using it or just applying this concept. So we'll go ahead and take a look at the first one. It talks about the sum of a two-digit number is 5. We just don't know what the digits are. So basically what they're talking about is we're talking about a digit, two-digit number like xy. See, the x is in the tens place. This is the tens place. The y is in the ones place. So this is our original number. And what they're saying here is the sum of these digits is 5. So I can rewrite this as x plus y equals 5. So for instance, the number x could be 4 and y could be 1. But x could be 1 and y could be 4. Or 2 and 3, 3 and 2. So those are the different options that we have. Now let's take a look at what this part says. If the digits are reversed, the new number is 27 more than the original. So what they are doing here, they're talking about a value equation. This is our quantity equation. So what we're going to do next is come up with the value equation. The value equation is the value of the digits. So if the digits are reversed, so let's take a look at the reversed. Reversed would be this, the yx. So now you see the y is not in the ones place anymore, it's in the tens place. The x is now in the ones place. So that's what happens when we reverse the digits. So again, if the digits are reversed, so let's go ahead and write out the value of that. So 10y, 10 because 10 is the y's place, and we multiply the value of y, like if y were, let's say, a 4, times by 10, that would be 40, because this would be in the 40s if y were 4. And then we have plus 1x, because 1 is, or the x is in the ones place now. Okay, so if the digits are replaced, the new number, this is the new number now, is 27 more than the original. So this number is bigger than the original. So let me rewrite the original number. Equals, okay, now the original number was, well, the x was in the tens place and the y was in the ones place. But they don't equal. Remember, this one right here is 27 bigger than this one. So let's do this. Let's just add 27 to the new, or the original number, because it says the new number is let's underline that part right there. New number is 27 more than the original. So that's why I had to add 27 to the original so that they would equal. So this is our value equation. So now we've got our two equations. So to solve, I'm just going to rewrite this value equation in a way that be a little more understandable. Get the x's and y's on the same side. So when I go ahead and do this, I'm going to bring all the x's and y's to the left. So let's go ahead and subtract this 1y, subtract this 1y, subtract this 10x, subtract this 10x. And when I do that, here's my new equation. I've got now a 9y minus 9x equals 27. Now I've got an equation I can solve. Let's see here. I don't have the y's and x's lined up, but I'll do that in just a minute. See how they both have a 9? Let's do this. 27, 9 goes into that too. Let's divide every number by 9. Let's see what happens. When we do that, now we've got a y minus x equals 3. Let's just take this equation and put it down below. And let's line up the variables. So it's a y, or x plus y equals 5. So I'm going to just rewrite the order. Y plus x equals 5. Now I can add these together and look what happens. I get those x's to cancel. But when I do that, careful, this is 1y and 1y, that makes 2y. 2y equals 8. Well, just one more step there. I just need to divide by 2, and we'll have the value of y. So y equals 8 divided by 2 makes 4. Well, to find x, just substitute back into the quantity equation. So remember, it's x plus y. Well, y is 4, we now know, equals 5. So x, well, when we subtract that 4 from all sides, we get an x equals 1. Well, what does this mean? Well, what they want, let's see. It says find the original number. The original number is xy, we said. So x is 1, y is 4. So there it is, 14. That's the original number. Well, why do we do this? Well, it just helps us understand how to use these systems of equations. Oftentimes, in real-world situations, we're looking for two different things, and we're using these two things at the same time. We want to find out what they have in common, and that's the point of intersection. And here's a case where we're just looking at these digit numbers. It was just a kind of a silly problem to solve, but it was something that we could use systems with. So here's another example of that same type of problem. Here we have the sum of the digits of a two-digit number is 7. All right, so the sum of the digits. Well, let's call xy the original number. And we'll go ahead and sum our digits together. X and y equals 7. Well, it says if the digits are reversed. Well, remember, the reversed is going to be yx. That's the reversed digits. And if we do that, the new number now is 9 less than the original. So let's go ahead and write the value of the digits reversed. So that would be 10y plus 1x. You see, y is in the tens, x is in the ones. And now the new number is 9 less. So this is 9 smaller than the original, 10x plus 1y. So remember, in the original number, x was in the tens, y was in the ones. Again, the new number, this one right here, is 9 smaller than this. So what do I need to do? Well, I need to make sure that I subtract 9 from the original, because it's 9 bigger. See, it says that the new number is 9 less than the original. So I've got an option. I can either add 9 to the new or take away 9 from the original. I chose just to take away 9 from the original. Now it becomes the same problem we had before. Again, all we're going to do is subtract this 10x from both sides. And then from there, I'll go ahead and subtract the y from both sides. And when I do that, now I'm left with a 9y minus 9x equals negative 9. And then from there, I can go ahead and do the same operation I did before. You see, they all have a common factor of 9. Take out that 9. Divide by 9. That's the same thing as multiplying by 1/9. And when you do that, you're left with this y minus x equals negative 1. We'll just take this top equation, this quantity equation, put it down below here, and then add them up. So I'm just taking this x plus y, and make sure you line up the variables though. Y plus x equals 7. And then add those together. Remember, it's 1y and 1y. So when you add that, it's not just y, it's 2y. So this time 2y equals 6. 6 because I subtracted. They're opposite in sign. And so when I divide by the 2 over here, I get a y value equaling 3. Well, just plug it into the quantity equation. So x plus 3 equals 7. Subtract the 3, and we've got our value of x. X is 4. So what do they want? Find the number. Well, they mean the original number. So let's go ahead and write that. So it's xy, so it's going to be 43. 43 is the original number. So those are some digit problems, just another way to use systems, and systems are always used in many different types of problems. One time I was trying to mix two different types of feeds together to come up with a certain protein level, and I used systems of equations to be able to do that. So systems are a type of problem that are always used, and here's just another instance where we can use them.